Are they like in the shape of flying saucers? Like, is that typically what we would see, is the classic flying saucer image, or they come in different shapes and sizes?
Actually, you're correct. They do come in different shapes and sizes. There are the classic lenticular or saucer shape, but then there are some that look like a tic tac, for lack of better description, and yeah, and some even are triangular. It's really rather interesting.
We're going to the point where we are already engineering material now at the atomic level. We're getting into nano level engineering. Nano, by definition, 1/1000th, of the size of a meter. So we're getting to that stage now.
My time at AATIP, there were some very smart people, not me, excluding me, but there were some smart scientists and whatnot who were able to come up with a very interesting theory, and that there is a certain technology that if you can master it, all those 5 observables are possible. We initially thought when we first started AATIP that maybe there were 5 separate exotic technologies responsible for each one of these observables, and you see the efforts in the DIRDs and all the reports that we did with the government on exotic propulsion and whatnot. But it turns out that if you know how to manipulate space-time, and not a lot, just a little bit, the space-time fabric of space-time, all these observables are possible. It also may explain why we're having this weird nonsensical return on radars. It also may explain why you don't have the associated issues such as air friction, like we said, right, and the acoustic signatures. It turns out that if you know how to engineer and manipulate space-time in a localized area, a lot of things that seem magical really all of a sudden become reality. And we've seen some of the micro experiments now at the CERN, the Large Hadron Collider, that seems to be substantiating a lot of this speculation right now.
So we're bringing in nuclear physicists and astronomers and cosmologists to understand extreme physics to explain what we're seeing on our F-18 radars and air traffic control radars and that kind of thing.
That is the next step, to open up the aperture of this and bring in under the tent a much broader audience, bring in people, contributors, bring in more scientists, more academics, bring in, if it was up to me, rather than being a UAP task force, which, as you know, in government terms means a temporary body to do a temporary job, I'd create an enduring capability. I would create something whole of government. I would do something like a federal national lab, like we have, bring in Department of Energy, FAA, NOAA, DHS, DOD, the IC, the intelligence community, bring everybody, la-di-da-di, bring in academia to come in from the universities and look at this. I would look at this topic very much like a peaceful version of the Manhattan Project, where we bring the best and brightest to look at this.
That's funny. Normally, I mean, the Russians have been stealing our stuff for 50 years, and the Chinese are obviously active in trying to steal our technology. But now we need to do the same thing to figure out what these things. We're basically the tables are turned on us.
I really want you to explain this cigarette analogy for me, if you can. You've used it a few times where you describe this cigarette as time. Can you run us through that real quick?
Yeah, sure. Let me start beginning with Newtonian physics, and I won't spend much time, but I think it's important to understand the context and how we have to shift our thinking when we're looking at space-time. So during the Renaissance, you have this gentleman, Sir Isaac Newton, who all of a sudden is able to quantify and qualify the observations we have in physics. Force equals mass times acceleration, have all these wonderful little neat mathematical formulas that describe the physics that we experience here on Earth, like gravity, the apple falling from the tree, and it's in a very real sense. It's physics in a physical sense. And then all of a sudden, several hundred years goes by, and some funny cat with crazy hair comes along who failed the 3rd grade and was a patent clerk, and proposes that the universe in which we live is not, in fact, linear at all. The universe we live in is a lot like think of a rubber band that can be stretched and compressed, and that the notion of space, the 3-dimensional space we live in, is inextricably tied to a 4th dimension called time.
Right.
So we have a three-dimensional space, XYZ axis, in which we can maneuver, and time being a function of the fourth dimension. And that very notion that space-time is flexible. It can be stretched and it can be compressed.
May I
That's really
say?
hard. Go
I
ahead.
was gonna say, I think of it as a sphere that just constantly moves outward. That it touches
is.
everything, as more of a rubber band that can even kind of be linear, but like a sphere, something that
Yeah.
it goes everywhere. It is
Yeah,
everywhere.
well, you're right. Maybe how about a big giant sponge, right? So a
Yeah,
big
perfect.
blob of sponge that you can pull and push and squeeze, and there's little holes in it. And so recognizing that space and time are tied together and they can be stretched and compressed. We live on Earth where our space time is relative to the perturbation or the disruption that Earth has on the space time around it. So if we were, for example, living on the moon or living on, let's say, Jupiter, where the gravity is much greater, or the moon where it's much less than Earth, we would experience time slightly different. It would time and it would go by a little bit differently. And the more massive of an object you're around, the more that is distorted till eventually you come to something like a black hole where it kind of just breaks down altogether and space-time doesn't even make sense anymore. So if you think of time, and I were to ask you, Luis, and I'm going to do this exercise with you again because maybe some of your audience hasn't heard this before. If I ask you, Luis, what is your, in the most simplest terms possible, one sentence or less, fewest words possible, what's your definition of the past?
That's a
Don't
good
overthink
question.
it. Don't overthink it.
So it's something that's already happened.
Something that's already
Perfect.
happened. Yeah.
Perfect. Michael, something that already happened. So I'm going to give you another chance here, Luis. With what Michael just said, if the definition of the past is an event that already occurred, what is the future?
Something that hasn't.
Great, right? Something that hasn't happened yet. What that means is that the present, in which where we live and everything that we experience, is not actually a moment of space-time. It's actually, if you were to look at, let's say, a fuse of a time bomb, right? Where the ashes that have burned are the past. That's real and it's there. That part of the fuse that has remains unlit. It's an infinitely long fuse that remains unlit. It hasn't ignited yet. That's the future.
Right.
The present is that infinitesimally small moment of space-time, probably measured in Planck time, where you have a transition between the future becoming the past. It's an illusion. It's not really a moment. It's a infinitely small moment that's moving forward. It's never static. And so by that definition, it's the present is really nothing more. Everything that we think and we love and we hate and we fear and all the memories that we have are gained from that very, 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 very tiny moment of space-time.
Yeah.
Why is that important? Well, because we know space-time can be flexible. And if you were to, let's take our analogy again of the fuse, right? Or a cigarette or a cigar burning, and you were to remove the glare and take, let's say, a microscope and really zoom in, you would notice something very interesting about the moment of ignition.
Right.
You would notice that the fuse, or that the cigarette, or that the cigar where the cherry is, that moment of ignition, burns unevenly.
Right.
In fact, there are portions at the very, very small, we're talking quantum world now, where moments of the past are actually now in front of the future and back and forth. It's an uneven burn until eventually you have everything is burnt and now you have the past.
Yeah.
So theorists right now, especially in the quantum world, have established a theory that says some of the observations we have with the electron, when we went to high school, we always learned that the electron orbited the nucleus of an atom. We now realize that's absolutely not correct. What we've learned now is it's called an electron cloud. And what's happening is that the electron is literally ebbing in and out of existence trillions of times per second all around, and you can never predict where it's going to go. And what scientists now believe is that the fabric of space-time at that level, when you're that small, is porous. There's holes, and you can actually zip in and out of the fabric of space-time, and now you're here, now you're not. Now you're here, now you're not. And this is important because when you think about space-time, we experience time pretty much in a linear fashion. but we experience space in a three-dimensional fashion. What if there is other things? We know that in the quantum world is possible. What if there are other things, other realities that time itself can be also experienced in a three-dimensional sense?
Yeah.
Meaning, we are having this conversation right now with your lovely audience, right here, right now.
Right.
But if I had the ability where my space-time was a little bit more flexible, if I was sitting right here 5 minutes from now, or right here 5 minutes ago, we would never be able to have this conversation. It'd be like two ships passing in the night.
Correct.
And so that is one of the theories that was presented at some time in long time ago in AATIP.
Okay.
And furthermore, it also might explain some of the other phenomenon, such as what we call remote viewing, or maybe psychic abilities, or precognition, human precognition. Because the human brain is a lot of scientists now that are neuroscientists believe the brain is really a part of quantum entanglement, and that there are quantum processes occurring in the human consciousness, and if that is indeed the case, then we may be able to up here, not necessarily here, but in our brains, be able to experience time in a slightly different way. We do know that when we have traumatic incidents that happen to us, a lot of people report everything going in slow motion.
Right.
And that may very well be experiencing the quantum state of human consciousness.
Yeah. Well, okay. So thank you for that explanation. It's beautiful. And I got excited as you were saying about it, because that's exactly what I wanted to hear, and that's how I remembered it. The fuse, okay, or let's say the cigarette. Does this phenomena, in your opinion, live within this cigarette?
Well, most of the universe does, and that's my point.
Right.
We have 5 fundamental senses that we view the universe, right? We see it, we hear it, we taste it, we touch it, we smell it, and that's it. But there is an entire reality around each and every one of us right now. You've got Wi-Fi signals coursing through your body. You've got radar returns coming in from the airport. You've got GPS signals coming down from satellites. You've got FM, AM coursing through your body. You've got cosmic rays coming in from outer space, neutrinos coming in from the sun. All this is occurring right around you right now, and you can't experience it because you don't have the equipment to. So take a nice, bright, starry night. Take a look at the beautiful heavens. You say, wow, honey, look at these beautiful stars. Now, if you were to look through that same exact night sky using a radio telescope, where you can see infrared and ultraviolet and all these other things, all of a sudden the whole universe lights up in front of you and looks completely different. Yeah. Now, it's not different. You just can't perceive all of that because we're human beings. Furthermore, when you look at that, and we realize that most of the world lies beyond our perception and comprehension, there's also a scalability issue. So I am a human being, and when I judge the universe relative to me, I know I can go in that direction 13.5 billion light years, and I can go that direction 13.5 billion light years, and that is the extent of the known universe. The visible known universe is approximately 27 billion light years across, and we are right in the middle, right? Now, with that said, from a scale perspective, the atom is 1 × 10⁻26 in size. So there is equally per scale just as large a space inside every single one of us as there is outside. And so, but we can't perceive it. The only thing we can perceive is something maybe 50 feet or 100 feet in front of our face. So by definition, 99.99999% of the universe, we will never be able to interact with, and we will never be able to see or to sense, because it's just where we are stuck in the universe.
Okay, so triangles. What else? You just said they're the size of a city block. They can go from 0 to 1 million instantly. What are they doing? Are they just moving around and observing us? Or
well, that we don't know. I mean, there's a lot of people that have theories. The problem for me is that we don't have enough data yet to really where one theory stands out more than another, and we need more data. And so I'm very careful never to offer my own opinion, because I don't think we have enough data yet. There's a whole lot of reasons why something might want to be here.
Intentions.
There's the practical. I mean, yeah, intentions, right? I mean, there's a practical sense that, you know, if you're really dealing with some sort of exotic technology, and there's so look, we know there's two ways to bend space time. Thanks to Einstein, E equals mc squared. And so what you have is either a lot of mass, like the Earth's mass is disrupting space time around us, perturbing it a little bit, and that's why our GPS clocks, this atomic cesium clocks, they run at a different rate than the clocks here on Earth, because the mass of the Earth is actually warping space time. So the heavier an object is, the more it warps space time. Well, same thing with energy. Just turns out you need a whole lot of energy to warp space time, and it's possible that, you know, if you really wanted to get to the fundamental elements of the universe, and so let me backtrack a little bit. The smaller you go in size and mass, the tighter energy is held in little packets, if you will. So if I take this glass of water and I change its phase, it's a 1 × 10⁻³ energy release, and it's called steam. And you know, for quite a while, we've been using steam engines to do a lot of our work, because it's an exponential to the 3rd times greater energetic yield. Well, it took the Chinese to realize that if you actually broke up the molecular bonds, a chemical, you know, exothermic reaction like gunpowder, that's a 1 × 10⁴ yield. And then we did that, of course, mankind realized that in the 11th century. It took us about another 1,000 years to realize, well, if I started splitting up the atom, not the molecule, but the atom itself, a fission type reaction, that's a 1 × 10⁵ yield, okay, in terms of kiloton yield. And then it took about 25 years later for us to realize, well, hell, I can break up the nucleus of an atom, right? And now that's literally a nuclear, not an atomic, but a nuclear yield, which is 1 × 10⁶, or better referred to as a megaton yield, and so forth and so on and so on. So the smaller you go down, right, the more energy is held tightly, but when it's released, it's much more. And so one of the theories is that perhaps if there was someone has figured out how to warp space time using energy, they could be using hydrogen, which is most abundant element in the universe, right? Because it's already kind of broken up to its fundamental atom. The problem is that if you wanted to mine hydrogen out in the universe, it could take you quite a while, because even though it's so abundant, it's dispersed. It's in gaseous clouds. There's only one place you find hydrogen where it is super concentrated, and that's water, H2O. Right. Once you find an oxygen,
you go in a star.
Yeah, or you go to a star.
That would be painful.
Probably would. Yeah, probably not advisable. So, you know, maybe the reason why these things are hanging out around water is because, frankly, we're just a convenient gas station. We simply don't know. I mean, there's all sorts of different hypotheses that have been put forward.
They were doing a nuclear test to explode a nuclear warhead in space, and allegedly something crashed in the ocean, and it was retrieved.
Let me. There may be some significance to EMPs. And I'm going to go out on a limb here, so please don't take this and anybody run to the hills. This is, at this point, pure speculation based upon some potential observations made in the past. There may be some truth that an electromagnetic pulse of energy can interfere with whatever this technology is and its propulsion. And if it interferes with it, then you now have a very interesting scenario where whatever is keeping these things up in the sky, it no longer does that. Can't do it. And so now all of a sudden, if you will, the bubble pops. And so all of a sudden comes crashing down this object that has no wings, no tail, no ailerons, no obvious signs of propulsion. And now it really does become a brick, and that brick falls. Now all of a sudden gravity has a say, and Mother Nature takes over. And that's probably what I'll say right now about that.
So first, I'm going to get to a question that I had, which is there a correlation between any of the characteristics of these UAPs, UFOs, and some other characteristic? For example, let's say that the tic-tac-shaped ones are more violent, or the pyramidal-shaped ones are faster. Is there a classification of them, and do they have some other characteristic associated with them?
So the characterizations that we have seen to date really is a result of size, believe it or not. So, and this is by no means comprehensive, but what we tend to see are the smaller vehicles tend to be think of a sports car, are your saucer shaped vehicles. Whereas the larger vehicles, let's say a school bus size, is that of a cylindrical object, or roughly that of a tic tac, or even sometimes described as a telephone pole. And then in shape, so cylindrical. And then the tend to be the large ones, really large ones, tend to be not always, but almost exclusively either triangular shape or boomerang shape. Now there are some anecdotal, if you will, reports of large saucers as well, and some shapes looking like a dumbbell. But the three primary categories tend to be that we saw in AATIP were disc shape, and then you have the longer cylindrical shape, and then finally a large triangular shape vehicle. The triangle vehicles are often described as flying very close to the ground and very quiet, silent, and seem to kind of lumber, if you will, from place to place, very slow, almost like you would imagine a large dirigible, perhaps, just kind of floating there silently. The apex of those triangles are often described with lights of some sort, or emitting some sort of radiation in the visible light spectrum, which to a lot of the if you will, people who reported this information, to include first responders, we'll often see the lights changing color, and maybe a result of some sort of Doppler shift that's occurring, red-blue Doppler shift. But that's in essence the three primary shapes that we have had reported.